One of the best ways to display your research statistics is through a beautiful plot. High-impact plots quickly tell your reader exactly the point you're trying to prove, while poorly designed plots leave your readers in a state of disbelief. My name is Jeffrey Franck. I'm a statistician and the CEO of Stat59. In this video, I'm going to walk you through 10 awesome plots that you can use to produce high-impact research. In this session, we are going to talk about 10 awesome plots that you can use to better visualize your research data. Fundamental to this is that we should always plot the data in some meaningful way. And why? Why should we plot the data? Well, there are a number of important reasons. One is that we can recognize unexpected trends. These trends can lead us to new hypotheses and ideas for new research studies. Readers vary in sophistication. Some of your readers may have a very firm background in statistics and be easily able to understand your methodology. Others may benefit by a graphical visualization of the data. P-values and confidence intervals, while excellent for deciding whether your hypothesis is likely to be true or not, can be very difficult to visualize for many readers. Often we can summarize many different important features of the data all in one single plot, and it avoids the monotony of reading a continuous text. For our first example, we're going to talk about data that has a time order. So in this example, a researcher suspects that the schedule of emergency shifts in her emergency department is poor. She feels that the volume of patients seen by each physician is unequal, and so she measures the patient volume for each physician for 1 week. So here we can see the use of the run chart. And run charts are very simple. On the x-axis, we have the index. In this case, the researcher started on Monday morning with the first shift on the Monday morning and measured each shift until the end of the week on Sunday night. And for each data point, she plotted the number of patients seen by the emergency physician. There are a number of advantages and disadvantages of the run chart. One of the main advantages is that the order of the observation is preserved. And this can allow us to assess for patterns. So you see very clearly in this plot that we are getting a cyclical pattern of very low numbers and very high patterns. One of the disadvantages of the run chart, however, is that sometimes our data really isn't ordered by time. And when it's not, it can be actually very difficult to make sure that we do not inject into our analysis patterns that are not really there. In our second example, we're going to talk about plotting of correlation. So here a researcher is looking at the correlation between the technical abilities score and the global rating score in a series of critical care simulations. So in this case, a group of participants are working on a simulation, and raters are independently rating them using two different tools, the technical ability score and the global rating score. And the question the researcher has is, what is the correlation? In this case, the simple use of a scatter plot can be very informative. Scatter plots basically plot an X and a Y variable to see how they are correlated together. So in this case, the Y-axis is the technical ability score, and the x-axis is the overall score on the global rating score. And this allows us to very easily see the trend and how the two of them move together. One of the major advantages of the scatter plot is this very quickly, very easily, we can see the correlation between the two variables. The disadvantages is that it can be very difficult to show the correlation between more than two variables. It is possible to make a three-dimensional scatter plot, but they're very hard for most of us to interpret. And scatter plots can be very overwhelming when there's a huge amount of data. when we get a massive number of little single ticks in the chart, it can be difficult to understand what they're saying. In this next example, we have a large amount of univariate data. So here, a researcher has recorded the systolic blood pressure for about 2,000 emergency department visits. And that's it. All we want to do is somehow express this number. And in this case, a density histogram is an excellent way to do this. With 2,000 observations, there's just too many to use a scatter plot. So here we can see a density histogram where the systolic blood pressure is broken into bins, in this case 20 units wide, and we see how frequently we see those measures. Overlying the density line on top is a nice way for us to look and see, does this tend to have a normal type distribution? Is this a binomial type distribution? One of the big advantages of histograms is that they provide this very quick overall view of the data. We can get a really good view here. We can see approximately what the average systolic blood pressure is. We have a pretty good idea what the highest and the lowest was. And they work excellent with huge sums of data. Some of the disadvantages, when we overlay the density curve, you see we get this sort of cryptic y-axis. And it's a little bit hard to tell, for instance, well, how many people actually had a blood pressure of less than 100? And the other thing we lose is the fine detail of each observation. In this next example, we talk about plotting the effect of factors. So here a researcher has recorded the amount of time it takes to triage a patient. And he's looking at the effect of the triage method and the experience of disaster training and the previous START training on how they influence this time. So here we have multiple different factors, and we're wondering, how does that affect the time to triage? One of the simple ways to do this is effect plots. And effect plots can be very easy to make. So here we see three different plots. In the first plot, we have the method effect plot. So we can plot the time, average time to triage a patient using the CTAS method versus the START method. Then we can look at the disaster training effect plot. We can see clearly the time to triage, whether you had disaster training or not. And then we can see the START training effect plot, which once again shows the same thing. So it's very quick here to take a look at the graphical representation. What are the advantages and disadvantages here? Effect plots are an excellent way to get a very fast overall view of the importance of certain factors. So here we can see quite clearly that the training method or the triage method and the START training seem to have a pretty good effect on speed of triage, where the disaster training seems to have no effect. The problem with effect plots is that many readers may not be familiar with these plots, and it can be a little bit tricky to sort them out. What's wrong with this plot? So we'll see very quickly something is completely wrong with this plot, an error that we would not want to make when we send these for publication, and that's that there are no units. So it's very difficult to know what this time is. Is that hours to triage 1,000 patients, minutes to triage 10 patients, or is it seconds per patient? So we should make sure that we don't forget our units when we're building these. In our next example, we're going to look at how to get multiple questions on one plot. So here, a researcher is looking at a satisfaction with the disaster medicine curriculum, and she's measured a satisfaction score for 4 different characteristics. And here's a time when using a bar plot makes a lot of sense. We see here on the y-axis the median satisfaction on a 0 to 7 scale with the various components. And we see that this was measured pre-curriculum and post-curriculum. So it makes it very easy for us to see the effect of the curriculum on several different factors. Advantages of the bar plot are that we can very easily see small differences. Small differences between the red and the blue bar, in this case, are very easy to spot. And it allows comparison of multiple groups all at the same time. The disadvantages are that it can be difficult to interpret as the number of levels of the factors increases. So here we see that we have 4 different pairs of bar plots. If you have a huge amount of data and you have 20 different questions, placing them on this type of bar plot can be very difficult. So what is wrong with this plot? What's wrong with this plot is the use of color. And the use of color, one must be very careful when using color whenever we use plots. If you are entirely in control of your plots, that is, you're going to be presenting them on screen for visualization or on your website, then it's one thing to use color. We have to be very careful, though, that many plots, particularly if they get published, will end up being printed, and they will often end up being printed in black and white, in which case a plot like this will become completely incomprehensible. So I advise caution anytime you're using color, and when in doubt, it's much better to use grayscale. In this next example, we're going to talk about 2 different continuous distributions. So here a researcher is looking at the difference between time to triage for CTAS, which is the Canadian triage guidelines, versus START coupled with CTAS. So here we have 2 different methods, and we're looking at the difference in time. This is a wonderful time to use a box plot. Box plots are an excellent, easy to understand way to plot continuous data. So in this case, we see very easily in the center, the bold line is the median for each of these methods. So we see the median time in seconds for CTAS is approximately 140, and we see that the median time for START triage is approximately 40. We can very easily see the difference. We also see some outliers. These little round dots are points that are outliers. And we see the upper and lower hinges, which you can think of as sort of a type of confidence interval. An interval that describes how clustered the data is around the mean. Now there are a number of advantages and disadvantages to box plots. Box plots are an excellent way to categorize the distribution of a sample. So we can see tight distributions or skewed distributions. And this plot is one of the best ways to get a large amount of data in one plot. The disadvantage is that it can be difficult to understand these for non-statisticians. If you've never seen one of these before, it can be a little bit tricky. So I suggest always considering your audience before we use this type of plot. In our next example, we're going to talk about prioritization. So here, a group of researchers has tested a group of residents in emergency medicine to see which areas of disaster medicine knowledge they are in most need of help. And the pretest scores as a percentage are available for 12 different knowledge areas. This is an excellent place to use a Pareto chart. So here you can see the chart on the y-axis. We have the proportion of questions that were incorrect. And on the bottom, on the x-axis, we have each of the different categories of questions. So the Pareto charts are excellent for using the concept of what is most important. So here, if we're designing a curriculum, we're looking at the highest proportion incorrect was in C4. So C4 might be where we want to start our teachings. Now, there are a number of advantages and disadvantages of the Pareto chart. The advantage is that it simply adds priority to a bar graph. And then it makes it much easier for us to understand why priority is chosen. One of the cautions and the disadvantage of Pareto charts is, remember that people's conception will be that the larger bars are more important. So you can see here we've actually sort of reversed what we've plotted. We've plotted the proportion incorrect, showing that the bar here, the first bar for C4, is the most important. So you may need to reverse your data to get that importance out. And what's wrong with this plot? Well, what's wrong with this plot is the lack of the legend. So one thing that may very well happen with your plots is your plots may at some point become separated from their text. Whether this is someone copying them and putting them onto an internet site or blog post, whether they simply get reproduced separate from the text. But we should always make sure that the legend is attached to the plot in close geographic proximity. So for this one, we should have a legend that describes what exactly is category C4, C10, C2. We should have a legend attached to our plot. In the next example, we're going to talk about how to add the concept of statistical significance to a run chart. So here, the same researcher who did the shift workload run chart, that was looking at the number of patients seen by each emergency physician on each shift in the emergency department, is asked by her colleagues, well, prove that these results were statistically significant and that this was just not by chance because you happened to catch us on a bad week. Here you see the same control chart with 3 lines. So here we see the red line, and the red line is the overall mean number of patients seen per shift. And then we see the blue control lines, and these are the 95% control lines that tell us when is a process outside of statistical control. So we see that those that are in between the blue lines are within what we would expect if we had reasonably distributed shifts, where those below the bottom control line are situations where the number of patients seen per shift are clearly lower than they should be. And on the top, those points that are above the top line are clearly out of control as far as too many patients are seen per shift. So what are the advantages of the control chart? Well, the control chart is a wonderful way to provide an overall view of the data with statistical hypothesis testing. One of the problems, however, is that sometimes the control limits are mistaken for specifications. So we should be careful to describe that. This chart does not say that the ideal number of patients to be seen by an emergency physician is between 16 and 22. It only says that is the control limits for what we saw. And we also need to understand the principles of repeated testing here. And sometimes we need to compensate for that. Plotting of ANOVA results can be super tricky. And in this example, we show an alternative to the ANOVA test. So in addition to the run chart and the control chart, the researcher for this same project on emergency department shifts did an ANOVA test that showed there was a statistical significantly difference between shift volumes. And none of our colleagues understood what ANOVA analysis means. And those of you who have read ANOVA results know that the increasing number of variables on the ANOVA make it very difficult to know what is important and what isn't. Often we get a very small p-value. We say the p-value for the ANOVA was 0.0001. Therefore, some factor is significant, but it doesn't tell us which direction and why. One of the ways that we can do this to project this very simply is by analysis of means. So here you can see what we've plotted is the different types of shifts per day. So number 1 is the first shift of the day, 2 is the second shift of the day, 7 is the last shift of the day. And we've looked at the mean patient volume and plotted them. And here we've put the red bar, which is the overall mean. And then again, we've added these control bars. And here the control bars are for the mean patient volume, which says that we should expect, if the process was equally distributed, if the distribution of the number of patients per shift was actually equal, we should see all of the points within the 2 blue bars. And here we don't, so we know that our process is not in control. One of the advantages of analysis of means is that it works very well as a graphical method to prepare several different types of groups. And it allows compensation for this concept of multiple hypothesis testing. It's well documented, and it's a nice alternative to ANOVA. The disadvantages is that it's certainly less well known than ANOVA, and if you're writing an academic paper, people may very well expect to see your ANOVA test. And so for this, you may need to explain the plot to your readers. In our next example, we're going to talk about linear regression diagnostics. So here a researcher used a linear regression equation to show a significant difference between triage methods and time to triage. And in a very, very common peer review comment, we got a reviewer who asked, how do we know that the linear assumption was correct? And any of us who are writing academic papers should expect that if you do not provide it, some peer reviewer will ask you about this. And here's where we can use residual plots. Residual plots, and there are a multitude of them, and we'll be talking more about them in a further video session. But it stands to say that residual plots are used to help decide how well does your prediction equation actually fit the data. And standard deviance residuals, plotting residuals versus the fitted values, and Cook's distance are all ways to do this. It is important whenever you're using linear regression that we make sure we include these residual plots. Now, what are the advantages and disadvantages of residual plots? Well, the advantages are that this is really mandatory for any time you use a study of linear regression. And they allow visualization of the representation of the utility of the regression equation that you've just built. And they're super useful for high dimension multivariate data. These are very difficult to interpret for most people, particularly in the case of logistic regression, and they may need explanation. For most of us, if we are including these in our methodology and in our results, we should explain what our interpretation of the values of the residuals are. In summary, these are mandatory, they're tricky to use, but we should get used to them if we need to publish about regression equations. And finally, a quick word about the pie chart. I think most of us have seen pie charts before. In this case, this is a survey of a group of individuals, and we plot them by their education level, by grade. And the grades are put into bins, and either master's, bachelor's, or levels of college. These are a common thing, and we see them all the time. Unfortunately, although there are some advantages, a number of disadvantages to pie charts. The advantage is that almost everyone is going to be able to interpret these. They're very easily understandable by most readers. And they do give a good overall view of the composition of the whole sample. So it's pretty easy to see by looking at this that most of the people here had education of grade 9 to 12, and not too many had a master's degree. We should use pie charts with caution, however. As human beings, our perception of area is very poor compared to our perception of height. So here it might be a little bit difficult to tell which was more common, a bachelor's degree or grade 1 to 5. It's also very easy for that reason to lose subtle differences. So if you need close comparisons, we should definitely avoid them. And pie charts are currently experiencing a very low popularity rating around statisticians. So how, in the end, do we make an awesome plot? When you make your plot, I advise following our awesome plot checklist. In summary, to be a good plot, a plot should emphasize or clarify the overall conclusions of the study. If the plot does not emphasize or clarify the overall conclusions of the study, it probably should not be there. Again, this goes back to my constant emphasis on what are you trying to prove. When writing a plot, think about what you're trying to prove. If the plot does not help you prove your point, it probably shouldn't be there. A plot should allow a typical reader from the intended audience to be able to understand the plot without reading the descriptive text. If the reader needs to read through the descriptive text in order to understand the plot, then your plot is probably too complex. Third, all details needed to understand the plot are contained in the legend. We talked about this, and that your plot may very well at some point become disconnected from the text. And we should be prepared for that to ensure that people can still understand it. The plot should emphasize clarity over cleverness. It is far, far better for your reader to see a standard plot that he or she is familiar with in a format that he or she is familiar with to understand quickly about your data, as opposed to seeing a new and beautiful plot that is incomprehensible. Consider grayscale and not color if the plot is likely to be printed. Make sure those axes are labeled appropriately, and make sure that the units are added to the axes wherever appropriate. Following these steps will allow you to produce your own awesome plots. In this video, we saw 10 awesome plots. We saw how matching the data type to the plot is critical, and we saw that overall, in the end, clarity beats cleverness when it comes to making plots. My name is Jeffrey Franck. I'm a statistician and the CEO of Stat59. If you'd like to see how the Stat59 web app can help you produce high-impact statistics quickly, please come join us at our website at www.stat59.com.